This video is going to talk about piecewise functions. Now, piecewise functions are just pieces of lines, pieces of functions rather than the entire line or the entire function. Right here, there's a example of a copy place, dittos. That's kind of an old word now. But anyways, the menu at the copy place might look something like this. Actually, it probably wouldn't look like this. This is more of a mathy thing, but you'll get what's happening here. X is the number of copies, and C is the cost. So here it says 0.15 times X, so 15 cents per copy, if the number of copies is between 0 and 25. 10 cents if it's between 26 and 100. That happens a lot of times at businesses, right? You buy in bulk, the cheaper the rate is. 7 cents if you buy between 101 and 500, and 5 cents if you buy more than a ream of paper, or 501 copies. So part A, go ahead and answer part A real quick. Hopefully you found that 450 copies, that falls within this criteria. So 0.07 times 450 is, hopefully you got $31.50. So what we're going to do now is we're going to draw a graph of this situation up here. So go ahead and draw. The only quadrant we need really is quadrant 1. So go ahead and draw quadrant 1. And if we were to scale this, I'm going to put 10 tick marks along here because 10's easy to eyeball. And 10 going up. Alright, so make a scale like that. Now, let's talk about our copies. X is the number of copies, and the y-axis, C of X, is the cost of those copies. Now, let's talk about X. X goes up to 500, and since we have 10 tick marks, a good scale would be by 50s, where each tick mark is 50. I'm not going to label all of those. Now the cost, let's go back up here. This first line, it says 15 cents for every copy. Now, if we buy 0 copies, how much is that going to cost us? Well, that better cost us $0, right? And if we buy 25 copies, the upper limit of this 15 cents times 25 is $3.75. Right? So now let's talk about the next set. Oops, I don't want that to be blue. 10 cents. So if we buy 26 copies, how much is that going to cost us? It's going to cost us $2.60. Right? 10 cents for every copy. So there's that. And then 100 copies is going to cost us $10. Go ahead and figure out these last two. I'll do it here. We already oops. 101 copies is $7.07. And then this last one, 501 copies is going to be $25.05. All right, so what is our highest cost? Since we have to scale our cost, we got to get up to 35. And since we're going by, we have 10 tick marks, maybe we went by 5s. It's an easy scale to go by. So go ahead and try and figure out how this is going to look here. Go ahead and press pause and give it a shot, or I'll show you in just a minute. So the first section, the red section here, is just a little line, just like that. right? Now, the next section of the line, the blue section, 26 and to 100, would look something like that, which brings us to the third section. The green one is the big, it looks something like this. And finally, the purple section, 501, would cost $25. Now, the rate is a little bit less than all these. Now, it might be a little bit tough to see, but you see how each segment gets a little bit less steep because each time it's getting a little bit cheaper. So it would just have to be a little less steep than what that green one is. This is an example of a piecewise function that's showing pieces of lines rather than the entire function. So part C says, using your graph, describe why. Part A is for suckers. Why is buying 450 copies for suckers? Because you could buy 501 for way less, right? For $25 rather than the $31,150. Businesses try and get you like that. Anyways, this is a real-world example of a piecewise function. Now, okay, so piecewise function, the way we're going to do a piecewise function is, this is saying f of x is this top line if x is less than -6, and f of x is this bottom line if x is greater than -6. In other words, I drew a dotted vertical line here on -6. This line is not part of the graph, but it kind of tells me what side each one of these lines is on. This line here is going to be on this side of that line, and this graph, this line here, is going to be on the right side of that dotted line. Now, the way you're going to graph a piecewise function is, step one, find the end point. But here's the thing. Put an S in parentheses because sometimes there's two endpoints. In this first one, there's only one. And the x value is -6. How do I know the x value is -6? Because that's what this is saying. Now, take that -6 and plug it into here. -4 times -6 is 24. Minus 20 is... Right? Now, we're going to plot that point, -6, 4. That is going to be an open dot. The reason why it's open dot is because it's greater than. Remember, greater than or less than are going to be open dots. Now, next thing you're going to do is use the slope. Use the slope to find more points. That can go away. So for example, our slope here is -4. Now, what I like to do is kind of remind myself which way is negative. Negative is like this. Through this point, left to right, negative is going to be like this. However, this line happens when x is less than -6, when it is on this side of -6. So I can't go down 4 and right 1. That puts me on the wrong side of it. Instead, I got to go up 4 and go left 1. Up 4 and left 1. I know it feels like you're going up, but when you draw that line, you'll see that it's actually from left to right, the graph is going down. Right? So now, let's do that again with this line. Now, the x value, first one, find the endpoint. So the endpoint is going to be at -6 because -6 is right here. Plug that in. 4/3 times -6 is -8. Plus 5 is -3. So -6, -3. This one is going to be a open or closed dot. Closed dot because this says x is greater than or equal to. Now, 4/3 slope is up and down like this, or would go like this. But again, it happens when x is greater than -6 on this side of -6. So, up 1, 2, 3, 4, 1, 2, 3. Use our slope of 4/3 to go up 4, right 3 to get another point. Up 4, and then draw that line. So this is our piecewise function. F of x is this line when x is on the left side of -6, and f of x is this line when x is on the right side of -6, greater than -6. That would be our piecewise function. Let's try another one. Number 2, how many lines do we have here? We have 3. So what I like to do is remind myself at -4, -4 and 5, and 5. So I'm going to put vertical lines on x's at -4 and at 5. Again, the reason why I do this is this kind of shows me where these lines are going to occur. There's going to be one line in this area, one between these two vertical lines, and one on this side. That's where our 3 lines are going to occur. In this area, the middle area, and on that side. So this first line, our x-coordinate is going to be -4. So plug in -4 here, -5/2 times -4, negative times negative is positive. That's going to be 10 minus 5 is 5. Now plot that point. Is it going to be open or closed? It's going to be closed. Now we have a negative slope, so again it's going like this, but it happens when x is less than or equal to -4, so that's going to happen on the left side of this. So instead of going down 5 and right 2, we got to go up 5 and left 2. The line should look something like that. Now when there's 3 lines, kind of a neat thing happens. This middle part, there's actually 2 endpoints. One of them happens at -4. The other one happens at 5. Right? -4 and 5 is where this line occurs, between -4 and 5. So plug those in. -4 minus 1 is -5. And then we're even going to plug this one in. 5 minus 1 is 4. So plot those 2 points. -4, -5. Is that going to be open or closed? Well, because it's less than there, it's going to be open here, but at 5 it's going to be, at 5, 4 it's going to be a closed dot. Then you would connect those 2 points. And that's what's nice about that. You don't got to worry about the slope or anything. Plot the 2 end points, and then I don't know if you noticed I put a little line here saying like if needed you use the slope. Well, this time we didn't need it because we have 2 endpoints and we can connect those dots. Now this third point, our x-coordinate is going to be 5. Plug that in. 3 times 5, 15 minus 10 is 5. So plot that point. Is it going to be an open or closed dot? It's going to be open. But we don't have a second point to grab, so this is another one where we have to use the slope of 3. Now, slope of +3 would look something like that, but it happens on the right side of this line. So from this point, go up 3, run 1, and that would be your graph. So that would be our piecewise function for this one. 3 distinct lines, none of them complete, just pieces of all of them. They're either going to be rays or segments the way they are here. All right, 3 is a little bit different. Again, f of x are these 4 lines, and this tells us when those lines occur. So at -7, at -3, at 0, -7, -3, 0, and that's it. So there's 4 lines, and we have 1, 2, 3, 4 different areas. All right, to the left of this line, between these 2 lines, that's our second area, 3, 4. Now, what kind of line is y is equal to 8? Well, that's a horizontal line at 8. Right? But here's the thing. We're not using that entire line. We're only using when x is less than -7. So from here, this way, that's it. So we don't need that whole line. We only need, up to less than -7. Now, is that going to be an open circle or a closed circle at -7? It's going to be an open. So it's a horizontal line less than -7. Now 6, this line occurs between -7 and -3. So at -7, that's a closed dot, because it was less than or equal to. And at -3, it's going to be open. And it's a horizontal line. You just connect those 2 points. Y is equal to 6. That horizontal line 6. But between -7 and 3, that's the only piece that we need. Then you got this guy. And then finally you got this guy. Looking like that. This is called a step function. A series of horizontal lines that look like steps. Alright, so check out what we did in example 2 and example 3 and try for yourselves. Yeah, it's a big one. If you can do that, I think you got it. Go ahead and pause it, give it a shot. I'll put the answer up in just a moment. Hopefully you got something that looks like this. Check your blue one. I know it was off the graph a little bit. Make sure your line is going the right way. The rest of these should have kind of came out like this. Smith out!